This is lesson 3 of chapter 2, and in this lesson we'll talk about classes of matter. And by classes we mean we're going to classify or organize matter into different groups. So the first class are mixtures. Now this is exactly what it sounds like. It's a blend or a mixture of two or more kinds of matter, each of which has its own identity and properties. So on the left side, you have just the black substance. On the right side, you have a red substance. And then in the middle, we have a mixture of the two. The black and the red still have their own identity and properties, but they are mixed together. The mixtures can be homogeneous. If the mixture is homogeneous, that means it's uniform in composition, which essentially means it's the same. Uniform just means the same throughout. So everywhere it's the same. And usually you cannot see the different parts of the mixture. So the visual here is a checkerboard, and each portion of the checkerboard is exactly the same. You can't really distinguish one side from the other. Here are some examples. Air is a mixture. Air is a mixture primarily of a few gases, usually nitrogen, oxygen, carbon dioxide. There is some argon. There's also some water vapor in air, but it definitely has more than one substance in it. So that's why it's a mixture. However, the gases are mixed perfectly. So one side of a room has the same composition as another side of the room. Sugar water, anytime you dissolve sugar in water and mix it well, you get yourself a homogeneous mixture. In fact, another word for a homogeneous mixture is a solution. And a sugar water mixture is a solution. A third one is steel. Now this is what's called an alloy, and on the next slide we'll define an alloy. But many metals are actually homogeneous mixtures, and essentially these are metals that are not found on the periodic table. They are considered mixtures. So by an alloy, what we mean is a metal made from mixing different elements. So for example, here you have keys are usually made of brass, which is a mixture of zinc and copper. Both of those are mixed together, and many coins are mixtures. It turns out if you make coins out of a pure substance, a pure metal, it rusts or corrodes much more quickly, so they actually alloy them together to give them different properties. And then finally, many rings are actually alloys. It also gives them superior strength and durability. So this, then we go on to the heterogeneous mixture, and hetero would mean different. So this is a mixture that is different, not uniform throughout. And so you can usually see the different parts of the mixture. An example here is this checkerboard pattern, and notice that one side of it is different than another side of it. So this is still a mixture, however it's heterogeneous. Concrete would be an example. In concrete you usually see rocks and maybe pockets of air, and you can see that it's not perfectly mixed. And then salad dressing. In salad dressing, especially the type you have to shake up, you can see that there are different parts to that salad dressing. A visual example we have here on the left side, we have a heterogeneous mixture because you can see the different parts. We have different types of nuts. So this is heterogeneous. Whereas on the right side, cake batter, if mixed well, becomes a homogeneous mixture. So perfectly mixed everywhere, and this one is not perfectly mixed, you could say. So this is mixtures. Let's also talk about pure substances. Now pure substances contain only one thing. They are not mixtures. You only have one thing in it. And they can't be broken down physically into anything else. Mixtures, for example, can be separated, can be broken down, and you can separate the mixture if you're careful enough. But pure substances cannot. And there are two classes of pure substances. There are elements, and these are what appear on the periodic table. And we also have compounds, which, as you'll see in a minute, are mixtures of elements. Now, every substance can be an element or a compound. The element is the simplest form of matter, and you cannot break elements down any further. So if you're at the elementals step, that's it. You can't break, say, carbon down into anything else. It's already at its lowest possible level. Same thing with oxygen. So both these are elements. You may be aware of them being on the periodic table. A compound then would be these two elements chemically bonding to one another. Now, they're not mixed with one another. They're actually stuck to one another permanently. Well, when you say permanently, chemically, strongly, we could say. So carbon dioxide, you may have heard of CO2, and water, H2O, are both compounds, and these are both pure substances. If you have water, if you have a cup of water, all you have is just water in there, nothing else. It's a pure substance. It's a compound. So here are two visual examples. Magnesium metal looks roughly like this. And then if you heat the magnesium metal up and let it burn, it becomes a powder, magnesium oxide, which you can hear that there are two elements here, oxygen and magnesium. These are both pure substances. One is an element, the other one is a compound. Now, each element or compound can be identified by their different properties. So if two pieces of matter have a different property, they are two different substances. And in these cases, what you see is a bunch of blocks. Each one of these is a different substance. And here you can kind of see it by color. Very often you can't see it by color, but you can do it by density, for example, by many other properties that they contain. And why not we summarize it here. This last slide summarizes for you what we've been talking about. All matter then is divided into two classes, mixtures and pure substances. Mixtures have different substances mixed together. And the mixture could be homogeneous, which means it's perfectly mixed, or heterogeneous, not perfectly mixed, or maybe you have big chunks everywhere. Usually you can see the different parts in a heterogeneous mixture, but not in a homogeneous mixture. If it's not a mixture, if it's a pure substance, that pure substance can either be an element or a compound. Remember, elements are on the periodic table, like carbon, like oxygen, like sulfur. And compounds are made of the elements, so like carbon dioxide. And these are considered the four classes of matter. So why not try an example? Here is practice example 3. See if you can identify these 5 examples as a homogeneous mixture, heterogeneous mixture, an element, or a compound.